Welcome back to my chemistry lessons. Today we are going to discuss how we can prepare salicylic acid from phenol. This is then an application of a Riemann reaction. So in a Riemann reaction, we discussed how we can prepare salicylaldehyde from phenol. Here we are going to show how we can prepare salicylic acid. So what is salicylic acid? Salicylic acid is there is a COOH group, carboxylic acid group, attached to the ortho position of OH group of the phenol. So this is called salicylic acid. So it's a phenol hydroxy benzene. So the same steps we are using here, what we have done in the previous lessons. So here the phenol is treated with sodium hydroxide. So phenol is going to treated with sodium hydroxide. So here is the phenol, there is an OH group, and that treated with the sodium hydroxide. So when phenol is treated with sodium hydroxide, you know phenol has acidic nature and sodium hydroxide has basic nature. So there is a salt formation like acid-base reaction and resulting in the formation of ONA. This is called sodium phenoxide. So the sodium phenoxide, how that sodium phenoxide forms, just like hydrogen from here and OH group from NaOH combine together and forms a water molecule. That's a dehydration, removal of water. So sodium phenoxide formed here, and the sodium phenoxide treated with the carbon tetrachloride in the presence of sodium hydroxide. So in the previous reaction we used chloroform here. So here carbon tetrachloride, because carbon attached to 4 chlorine atoms, that's why it's called carbon tetrachloride. And here what happened is the sodium combine with one of the chlorine atoms here, so resulting in the formation of NaCl, and there is hydrogen here. So there is a hydrogen here, hydrogen here, hydrogen here, hydrogen here, hydrogen here. One of the hydrogen of the close to the ONA group combine with the OH group of sodium hydroxide and resulting in the formation of water. There is again dehydration. So the resulting compound will be like this. There is a benzene ring and there is a ONA, and there is a little bit changes here now. The hydrogen replaced with the C, and one of the chlorine combined with the sodium forms NaCl. So there is a one chlorine less, so there is a CCl3. So there is a CCl3, and in that stage again just treated with the sodium hydroxide. So our purpose is removal of this chlorine from here. So when treated with the sodium hydroxide, what happens is the chlorine combined with the sodium. We need 3 sodiums, so we put 3 NaOH. So we will be getting NaCl. How many NaCl? 3 NaCl will be eliminated or removed. So in that place is substituted with the OH group of sodium hydroxide. So resulting in the formation of a compound like this, ONA, and here COH, one chlorine replaced with OH group, other chlorine replaced with OH group, other chlorine replaced with OH group. So this is a very unstable compound because 3 OH groups and 1 benzene ring attached to this carbon atom. So this compound wants stability through dehydration. So what happens is this bond breaks and this bond breaks and forms water again. So what happens when this bond breaks? Oxygen has a valency and that valency combined with the valency of the carbon here and forms a additional bond. That's called pi bond. So the same thing happened in the previous reaction, the formation of salicylaldehyde. So C double bond O will be formed, and that group is called carbonyl group, isn't it? So here, what happens is again dehydration takes place and result in the formation of ONA, and here C, there's an OH group there, I don't want to touch that, and here what happens is there is an additional bond formed between carbon and oxygen. So here COOH, that group is called carboxylic acid group, COH group. So this is a sodium salt of a salicylic acid. So here we have to remove that, we have to exchange that Na with the hydrogen. So we just acidified with the hydrochloric acid. So the chlorine and sodium combine together and forms NaCl, and that hydrogen goes to oxygen. So we'll be having OH here, and here COH there, and there is a double bond. So this compound, so we can write like this, same as like this, benzene ring, and here OH group, and when we combine all these groups like this, COOH, and this is called salicylic acid. Salicylic acid. So we converted phenol to salicylic acid. I just put the both are equal, isn't it? Or you can write or. We just abbreviated the group like this, you know. So or salicylic. Or I can write straight away like this. Salicylic acid. I don't want me confused you. Okay. So this compound is called salicylic acid. So this is a very important name reaction in organic chemistry, and this is the method for the preparation of salicylic acid from phenol.